So hello and welcome to the walkthrough series, and in this episode we are going to be looking at the Java solutions to the question 1 of the 9618 variant 4.1 May-June of 2021 solution. So without further ado, we have the paper open right here. We're just going to go ahead and jump right into the first question. So there's that information. Make sure that your name, blah blah blah. Then evidence document, they're telling you the format with which you are going to name your evidence document. Then the question actually starts right here where it says a class declaration can be used to declare a record. A list is an alternative to an array. That one is a piece of information for those that are writing in Python. But for VB and Java people, this first statement right here is actually a giveaway or a hint to what you are going to be required to do in the question. So question 1 says that an ordered linked list uses a 1D array to store the data. Each item in the linked list is of a record type node with a field data and a field next node. The current contents of the linked list are, so we are given the current contents of the linked list right here. Then question 1 says here that the following is pseudocode for the record type node. Then we can see the pseudocode declaration of a custom type of a record rather called node. Then the question says that write program to declare the record type node. Save your program as question 1. Copy and paste the program into part 1 of the evidence document right there. So if you remember when we started, we were given a hint right there when they said that a class declaration can be used to declare a record. So that's actually what we are going to do in this particular instance. So switching to the code right here, you see that we have the class declaration. Let me just open up my side panel and open the node class right there. Control B to collapse that side. Maybe let me just zoom in a little bit so that you can see better. Alright, so from the pseudocode right here, we will see that we need to declare a class called node. So you see that number 1 here, the solution is that we are going to declare our class called node as a public class, right? So that we can access it in other files besides this node.java file. Then remember that the convention for Java classes is that they should have a capital letter N. So this is despite the fact that you can see that the node type right here, the identifier for node is all small caps, but we have to follow the convention for the programming language, which is Java in our case. So we have two variables going on in there. We have data and the next node, both are of type integer. So we are going to create our instance variables, or more specifically fields, as described in the was described in the plain type today. Okay, there we go. So if you remember here, they said that the field with the field data and next node is it. So these instance variables are essentially our fields for this particular record type that we are declaring in this case. Then for just doing that, having this class called node, you can ignore the getters and setters for now, right? We're just focusing on the record type, on the record or on the class called node right here. Now, the reason why we have these, the constructor as well as the getters and the setters for this particular example, or rather for this particular question, we'll get back to that as we progress with the question. But I'll just quickly point out that for you to declare instance variables in Java. Instance variables in Java should be declared as private, is it? So when you declare variables private, and if you now want to access that private variable outside of that particular class, you cannot access it directly because it's only visible in this particular file. So later on, when you create another file, which is question 1, we are going to write code that requires us to make access. That's going to require us to access these private fields. So that's why you see that we have these getters and setters right here. And really, it shouldn't be a big deal declaring getters and setters, even if the question doesn't really ask for it, because these you can automatically generate in any IDE. Like for instance, maybe say in I think in any IDE really, whether it's NetBeans or IntelliJ, if you just right click anywhere in that particular Java file, you should see an option where it says insert. Then you can generate your getters and setters automatically, so you don't need to worry about having to include the getters and setters. It's not really an issue because it's actually how you are going to access those private fields or instance variables in Java, so you'd actually need them later on. So that's why you see that we have these getters and setters declared in this particular instance. So for this question, it's just 2 marks for declaring the class node with the two fields or instance variables, namely data and next node. Then moving on to part B, it says here that write program code for the main program. Declare a 1D array of type node with the identifier linked list and initialize it with the data shown in the table on page 2. Declare the pointers. So this is the data that they are referring to, right? So we are supposed to declare a linked list with this particular data. So to address that, to come up with the solution for that, you need to create a second file called question1, like in this case. Then after doing that, you see that our solution to 1B starts right here on line 6, and you can ignore the suppress warnings that I have going on there. That it's an annotation in Java. You don't really need to worry about it. Even if I were to remove it, still my code would work just fine. So maybe I might just as well comment it out so that it doesn't distract you. So the main program, so whenever you hear them say main program, it means that you now have to write the main function. So we have our main function going on line 8 right there. Then we need to declare 1D array. So this is our 1D array declaration on line 9, right? So remember, it's of type node, is it? So we have the type, it's node, and those box brackets indicate that it's going to be an array in Java. Then they said that the identifier should be linked list, and that's what we did right right there, that instance. And then we used the new keyword to create an array that's going to hold 10 elements of type node. And how did we know that it's 10 elements? Because we were given indices right here, and you can see that the indices are running from 0 to 9, and that's how you know that you should have 10 elements inside of your inside of your linked list. Then it also says that you should declare the pointers, is it? So the pointers in this particular instance are start pointer and empty list. So int start pointer and empty list right there, that's on line 10. That's us declaring our pointers. Then it also says that you should initialize it with the data shown in the table on page 2. And the initialization is going on from line 12 to line 22. So you can see that you can see right here that we are now accessing, or rather assigning, elements to the linked list. So the element on index position 0. If you look at the table right here, it should have data 1 and the next node 1. So that's what we are doing right here, is it? So now when we are now assigning values to this particular node class, remember that we have our node constructor right here, is it? We did have a constructor in this particular instance, and this constructor, you can see that it takes 2 arguments or 2 parameters. So it's going to take the data and the node, is it? And each time we want to assign an element to a particular position, like let's say the first position of our linked list, right? We are now calling the new constructor, and we are now calling the node constructor by using this new keyword, is it? And we are telling that when you create an instance of a node, you should give it a data of 1 and the next node 1, just as it is indicated right here in the table. So we are going to do that for all the other for the remaining 9 nodes. So you see that the data that we have going on here matches the data that is inside of this table, and also the indices right here also matching the indices that we have going on there. Then for that, you are going to get 4 marks for just creating the main method, declaring that array and the pointers, as well as assigning values to the array elements, as it were. Then part C says here that the procedure output nodes takes the array and start pointer as parameters. The procedure outputs the data from the linked list by following the next node values. So write program code for the procedure output nodes. So save your program, and we're going to have to paste it to the evidence document. So let's actually go ahead and look what we have going on in here. So you see that the procedure output nodes takes the array and start pointer as parameters. So whenever you see procedure in Java, just know that the return type is going to be void, is it? So you're just going to create a method that is a return type of void. So it's public and it's static, meaning to say that we don't need to create an object for us to use this particular procedure. That's why it's static. Or in other words, we're saying that this output nodes method or procedure, it belongs to the class. It doesn't belong to an object. So that's why we are saying you don't need to instantiate an object to use output nodes. Then it says here that it should take an array. So you see that we have a node array right there as the first parameter. Then the second parameter is the start pointer, is it? So it's important to realize that start pointer in this particular instance, it's not the same start pointer that we have that we declared inside of main, is it? This one is a local start pointer. Remember, local and global are variable scope in Java. So now what we are doing is, if you remember the description that we read right here, it said that the procedure takes the array and outputs the data from the linked list by following the next node values, is it? So we now have to initialize a variable called current node to the start pointer that would have been created, that would have been given as an argument to this particular method, so that we are able to output following the next node values, is it? Then we are going to use a while loop to output the data as well as the next node. So we are saying that while the current node is not equal to -1, because remember, when you have a value of -1, it means that there's no next node. In other words, that is an empty what? That is an empty slot right there. So while the current node is not equal to -1, right, what we want to do is we want to output the data, right? So we are using, we are now taking the array that would have been passed as an argument right here. Then we are pointing to the current node. Then remember that the current node was declared as a private, is rather a private instance variable in this particular instance. So we have to make use of the get data getter that is inside of here. So that's how we can access private fields in another class. So we are using .get data, and the current node is going to be set to be equal to the array, the current node, then we get the next node, is it? So that's how we can actually go ahead and output our nodes in the linked list. Then we copy this code, and you are going to paste this code inside of your evidence document. Then moving on to part C. Part C item 1, that's what we're doing. Now we are moving on to part C item 2. Add the main program to code the procedure output nodes. So the main program starts right there. Remember, the main program we'd actually written it before. Then our solution is right here on line 24. So we are supposed to code the procedure output nodes. So basically what we can do is we can just have a simple print line statement, right? That's just going to announce that we are outputting the nodes starting from whatever index that we have going on there. So we now call output nodes on line 26, right? And we pass the linked list as a parameter, as the first parameter, because remember, this output nodes takes an array, is it? So our linked list is actually 1D array, then the start pointer, that is where we want to start. And our start pointer value, remember, it's currently 0, so we are going to output our nodes starting from current index position, which is 0, all the way through. So that's how we are going to actually output our nodes, as it were. Then it says here that take a screenshot to show how the procedure output of the procedure output nodes. So in this particular instance, you now actually have to run your code. So let me go ahead and run this code. Let me just clear the console. Then we compile our Java file, question1.java. Then we now run our file. So question1 is what we want to run. So you see that it says here that outputting nodes starting from index 0 is it. So we output the nodes 1, 5, 2, 6, 56, and 7. Then you take a screenshot of this and you paste it inside of the evidence document. You can ignore this for now because this is part of the this part is coming later on in the question. I already returned the entire solutions. So maybe what I can do in this instance, I can just press Ctrl C to interact with the keyboard so that we close out of that. Alright, so moving on to item number so item number 2 is done. Now we move on to part D. So the function add node. So whenever you see a function, you need to know that you are going to have a return type, is it? So the function add node takes the linked list and pointers as parameters, then takes as input the data to be added to the end of the linked list. The function add the node adds the node to the next available space, updates the pointers and returns true. If there are no empty nodes, it returns false. Write program for the function add node. So let's look at the solution to 1D. It's quite long, right? The solution, and it's also reflected right here in the number of marks that have been given for this particular question. So what you need to do is to have the proper function header. So remember, this is going to return true or false depending on whether we have space to add the next node or not. So our return type is actually Boolean in this case. Then we were told that it takes three parameters, that is the array, then the pointer, then the pointers rather, that is the start pointer and the empty list pointer. Then this function is actually supposed to also take in the data that's going to be added to the next available space, or rather to the end of the list as it were, linked list. So here we declare a variable called data to add, is it? And since we have a start pointer, we also want to take track where our end pointer is. So we have this end pointer variable going on there. Then since we're actually going to be adding a new node to the linked list, we actually need to declare a variable called node, and our identifier in this case is going to be the new node that we want to add to the linked list. Then we are creating a scanner object called keyboard that's going to allow us to input using the keyboard, which is our standard input, or in this particular case. Then we just put out a prompt which says that enter data to add, so that the user knows that they should type in something, so that it can be added to the linked list. Then we are using the keyboard object right here to take the next integer as input and store it inside of the data to add variable that we declared earlier on line 49. Then to avoid resource leakage, we are simply going to close the keyboard, or rather the scanner object called keyboard, because we are done with taking input. Then on line 55, we are now checking to see if the empty list is not less than 0 or greater than 9, is it? If it is, if this condition is satisfied, it means that we are going to return false. And false, remember, it means that there are no empty nodes, is it? So it's going to return false. But otherwise, if there are empty nodes, it means that we can actually insert something, is it? So it means that we can actually go ahead and try to insert a node. So our new node is going to be, now we are creating, rather we are actually passing values to the new node that we have created right here on line 50, is it? So we call the node constructor and pass the data that was input by the user, as well as the pointer. Is it the pointer? Actually, it's the next node, is it? So the data and the next node, that's what we are passing right here on line 58. Then we are now checking to see, we now take the new node and put it on this array, this index position called empty list. And remember, this would have been supplied by the user when they called this function. Then we are now checking to see if the start pointer is equal to 0. So if the start pointer is equal to 0, it means that the start pointer is going to be equal to empty list. That is whatever value was passed is empty list right there. Otherwise, the end pointer is going to be the start pointer. And what we are going to do is we are now going to try and iterate over the nodes to check and see if we are able to edit. So what we are saying in this case is we are saying while the array, that is the value that is being pointed by the end pointer value, we get that node and check to see if it is not equal to 1. And if it is not equal to 1, then it means that our end pointer is now going to take, is going to be assigned the value of the next node right there. And then we end by setting our next node to the empty list. Remember, this set next node variable is right here in our setter, is it? So the set next node method, what it does is that it takes a node, is it, as an argument, then it sets it. It takes the instance variable and sets it as the new node that was passed as an argument right here. So that's what we're doing in that particular instance. Then we return true. So this is the implementation of the add node function. Then we come here to the question. So add the main program. So we are done with the implementation, 7 marks for this. Then add the main program to core add node, is it? So we come back to the main program, and you see here we say that where did we? It's D item 3, is it? Yes, actually D item 2. So what we need to do is we need to core add node. Then we need to output an appropriate message depending on the result returned from add node. Then we are also going to call output nodes twice before calling add node and once after calling add node. So what we do in this case is that we are going to have a boolean code result. Why do we need this boolean value? Because remember, we are going to output a message depending on whether we were able to add or not add a particular node, is it? So we have this boolean code result, which is going to hold the value that is returned by add node. Remember, add node is going to return a boolean true or false, is it? So whatever value add node is going to return, we are going to hold it inside of result. Now we say if the result is true, we are going to say that we were able to add the node successfully. Otherwise, if the result is false, then we are going to output a message which says that the node was not added. Maybe let's say node was not added, like that. Then we were instructed here to call output nodes twice, is it? Once before calling add node, which is what we are doing right here on line 26, and once after calling add node. So after add node, remember we are calling add node right here, is it? Then we hold the result and we output an appropriate message. Then we are now calling output nodes one more time. Then save your program, copy and paste the code into the evidence documents. So for just doing this from line 29 to 35, you're going to get 3 marks. Then the final part of the question says here that you should test your program by inputting the data value 5 and take a screenshot to show the output. So let's actually go ahead and do that. Open our terminal. I think maybe we need to compile the code one more time since we made some changes. Then let's run it, and you see that it first outputs our data, right? Then we're told to input the value of 5, is it? And take a screenshot of to show the output. Then we hit enter. So you see that it says that our node was added successful. Then data, you see that this time we now have the node 5 added to the end of what? To the end of the linked list. Then this is where you would go ahead and take a screenshot of this entire code and paste it in the evidence document. So yeah, that's just about it for number 1. I'll see you in the video for number 2.